Welcome to myprojectwizard.com. Let we discuss about the process segmenting retinal blood vessels with deep neural networks. Let me see the abstract of the process. One of the well-known and commonest diseases that need a computer-aided medical diagnosis is diabetic retinopathy, which leads in most cases to partial or even complete loss of visual capability. The accurate diagnosis of this disease depends upon some features which have to be analyzed in order to qualify quantify the severity level of the disease. Retinal blood vessels are considered as one of the most important features for the detection of diabetic retinopathy. The segmentation of blood vessels from the retinal images can be done based on classification or segmentation process. In the segmentation process, morphological segmentation and thresholding process were employed. In the the classification process is based on the features extracted from the image pixels and classification of the pixels into retinal portion or blood vessel portion. The extraction of blood vessels from retinal images is an important and challenging task in medical analysis and diagnosis. Retinal images usually have pathological noise and texture backgrounds, which may cause difficulties in extraction. The line type feature of the blood vessel is not changed when the background textures of the images are different. Identifying and locating the blood vessels in fundus images is a critical process since blood vessels were similar in intensity compared to other regions in the images. The process of extraction of the blood vessels is initialized by the pre-processing of the retinal image. Pre-processing is employed in two stages based on global contrast normalization and zero phase component analysis. The pre-processing step enhances the input images and they are used for the extraction of the features. The pre-processing process is also helpful for the normalization of the intensity in the overall input images. The blood vessels regions were segmented with the help of convolutional neural network classifier. The performance of the process is measured based on performance metrics like accuracy, sensitivity, specificity, area under curve, and kappa. Let me see the flow diagram of the process. The input of the process is the fundus images extracted obtained from the dataset. The fundus images were initially pre-processed with the help of global contrast normalization and zero phase component analysis. The global contrast normalization process normalizes the contrast all over the image based on the patchwise separation of the input image and normalizing the patch based on the mean and the standard deviation value of the patches. After the global contrast normalization process, a zero phase component analysis process is employed in which the the optimization of the pixels were done based on the widening of the image pixels, which represents the overall normalization of the pixel values. After the pre-processing step, we move on to the convolutional neural network. The convolutional neural network takes the input images as input and we train the dataset and we give the trained values and the labels to the classifier. Based on those values, the classifier classifies the input image pixels into blood vessels regions or not. So if the region is classified as a blood vessel, we set the value as a 0 or else we set the value as 1. Thus, the blood vessel regions were displayed in black color regions and the normal vessel regions were displayed as a white color region, and from that we segment the extracted blood vessel regions. Finally, the performance of the processes were measured based on the performance metrics like accuracy, sensitivity, specificity, area under curve, and kappa. Let me see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the process executed. First step is we have to select any one of the fundus image from the dataset. So we have selected a fundus image. The process goes on. This is the input fundus image that we have selected. So we have to segment these blood vessel portions from the fundus image. This image is obtained after the global contrast normalization of the input image. As we can see, these two images were visually similar, but the contrast O is the of the overall image is normalized. The next step is the zero component phase analysis. So in this process, the image patches were differentiated and they were matched in order to identify the exact portions of the retinal images. In this, the patches of the input images were separated in the randomized order and the whitening process is applied. So as we can see, this is the segmented blood vessel regions extracted from the input image. So as we can see, the blood vessel regions alone were segmented from the input image and they were represented in black color. The other portions were represented in white color. So thus we have obtained the blood vessel regions from the input image. After that process, we extract the performance for the proposed approach. The performance of the process is measured in terms of performance metrics. These are all the performance metrics used for the process. So the calculated performance metrics indicates that the proposed approach has more efficient segmentation result compared to the other existing approaches for blood vessel segmentation. Thus, we have segmented the blood vessel regions using the convolutional neural network process, and the segmentation process is based on the classification using the neural networks, and it is preceded by the pre-processing steps based on the zero phase component analysis and the normalized uh, normalized contrast in global contrast normalization process. Thank you.